There we go. We are in the middle of our really big systems unit. Here's our second learning card. Again, number this as your teacher has labeled these. I think we're is again depending upon which semester we're in. But here we're going to be talking about card for systems by substitution. So, solving my systems by substitution. The key here, step number one, hence the little key, get it? Huh? Anyway, look for a single variable to solve for. So in this case, as you look at that equation up there, you've got 3x plus y is equal to 1, negative 2x plus 3y is equal to negative 19. That opposite of y, excuse me, the y on the first equation is just kind of screaming, get me by myself. Because that's going to be a good substitution step. And that's actually, to be honest, one of the hallmarks of saying, you know what, this would be a good problem to do by substitution. So for step one, we are going to take 3x plus y is equal to 1, and we're going to solve for y. If you want, pause it here, do the work, and then double check it. So you subtract 3x from both sides. And you can write this a variety of different ways. You can write this as 1 minus 3x. You could write it as negative 3x plus 1. Either way works. But that is now what we're going to be using. So we're going to circle it since it's important to us. And then step 2, we're going to substitute or replace. Some people are finding the word replace better. So we're going to substitute that y now in with the 1 minus 3. And so that's why I actually have this little double arrow thing over here. So that's kind of our big idea. Because remember, we can exchange these. 1y is the same thing as 1 minus 3x. And so they're interchangeable. You can use either one. It's the same thing. So for step 2, it's going to look like this. So take negative 2x plus 3, and then I'm going to substitute in or replace the y with 1 minus 3x. Go for that. So we took out the y, put in something of equal value. It's not like the store where it's equal or lesser value. It's equal value. And then step 3, we're just going to solve. Solve for the remaining variable. So step 3 will look like this. Sorry, my cord is hitting my microphone.
Here we go.
Sorry if there's a glitch. I was interrupted. Good job, Lupe. So we're going to go ahead and distribute this out. So for step 3, we're going to solve. Do the distribution. I'm going to change colors here so it doesn't all bleed together. Combine the x's. And then you just do it again. It's just like semester 1. And so as you go, we're just going to undo everything, and we get x equals 2. Again, we'll box it because that's important. And now we're 2/3 of the way done. The one warning which I have is some people like to stop right here. And because they're like, hey, I got a variable, I got an answer, there's an equal sign, life's good. But remember, we're actually trying to solve for a system of equations. Each equation is a line. We're looking for a point that makes both equations true, which is the whole point of this. So for step 4, we're going to substitute value and get the other variable. Does not matter which equation you plug it into, remember. So I'm going to just use the top one. 3x plus y is equal to 1. And I'm using the top one primarily because I already have a y by itself. It just makes life a little bit easier. So before I forget, this is step 4. This again, remember, the reason why I'm labeling this out is that the goal here is that you want to be able to look back here in a couple of months, if you need to, or a year in Algebra 2, and then be able to read what's going on and understand what you were doing. So I get positive 6 plus y is equal to 1. I was already anticipating the negatives. So y is going to equal negative 5. And some people think this is enough. But again, remember what I said. We're having a set of points here, right? So we've got one line going like this. We've got another line going like this. Your solution is right there. It's the point of intersection, which apparently doesn't work when I do a magic pen on a magic pen. But a point of intersection has to be written as a point. So remembered, put your answer in it as an ordered pair. So in this case here, step 5, we're going to write as an ordered pair 2, comma 5. And that is your final answer. Now a couple things to remember here. Be careful, okay? You need to watch the details. Because if you make a mistake in the details, everything is going to fall apart. Okay? So watch your negative signs, etc. And everything, you should be okay. Now the last two, for sake of ease, I've already done the substitution step for you. So on both of these, there was a system of equations. I did the substitution step, and these are special cases like we've had all the time. And so I just wanted to make sure that you guys had an example of that. So after the substitution step, you get to this, and we solve it. So we distribute it out. 4y minus 10 minus 4y is equal to negative 10. And you can probably already see this coming, obviously, but the y's over here equals 0. Do not write down 0y. I found whenever people do that, they lose the 0, keep the y, and then mistakes are just bad. But anyway, so now we have a true statement because we get negative 10 is equal to negative 10. So because of that, that means we now have, it's the same line. So not only do we have the same slope, we have the same y-intercept. So we have infinitely many solutions. So there's that case. Over here, same idea. Distribute out the negative 2. And again, this would be an example where, watch your details. We're distributing a negative 2 here. So it's going to turn out to be 6x minus 6x plus 14 is equal to 5. So again, these are going to equal 0 here. So I get 14 is equal to 5. That is false. Remember, when you get a false statement when the variables disappear, that means you have no solutions. Okay, so that should get you set for this. Obviously, rewind it as you need to, like, comment, subscribe, and all of the other good things that you good people do. As always, have questions, talk to your teacher, talk with me. We'll see you in class.